Teams shared.
Yeah, I start recording the session.
Perfect. All right. Good morning, ladies and gentlemen. Welcome to our webinar on the project C-Service, which will show you circular economy in practice in the electric and electronics sector. My name is Konstantin Hermann. I'm Director Sustainability Consulting in Manufacturing and Electronics at Sphera. And I'm in the advisory board of the C-Service, and I will be your moderator today. You might have expected Elke Smith from Philips. Unfortunately, he got tied up on short notice, so I have again the pleasure for a second time to moderate the interesting outcomes and contents of the project. And before we go in detail, please, some housekeeping rules for all the attendees. Thank you for your interest, by the way. We will record the webinar. It's already ongoing. The next 1.5 hours is covered with of a good of an hour, 1 hour 10 for presentations, and we will reserve the last 20 minutes for questions and answers. So please, as you are muted, also to reduce noise, etc., please write your questions in the chat, also during the presentations. We will take care to sort them out and bring them up in the last 20 minutes. Just in case we face too many questions that we cannot cover all the answers, then we will follow up with you directly by email from the consortium. That so far from the introductory side. Let me hand over to the webinar content. We will hear Fatima Aparicio Rubio from Aimplas on a short introduction of C-Service. And she works as in the mechanical recycling group in Aimplas, a Spanish company that is also the coordinator of C-Service. So please, Fatima, take over.
Hello. Hello, good morning. Thank you to the organizers of the meetings. Thank you for the audience, ladies and gentlemen. I'm Fatima from Aimplas. I'm one of the project coordinators. Okay, so let me introduce yourself, introduce the project, okay? Waste electrical and electronic equipment involves a large number of different products that are disposed when they are no longer in use. Large household appliances such as washing machine and television are the waste that is collected the most, followed by computer equipment. This accounts for 70% of the waste electronic equipment we collected, and are the types of the waste that, due to their significance, are included in this project. More than 27% of worldwide WEEE generation takes place in Europe. Only one third of WEEE generated is reported as properly collected and treated. And every year, the world discards around 50 million tons of electrical and electronic devices. The content of electronic waste are as varied as they are valuable, containing up to 60 unique elements. These range from base metal like copper and tin to precious metals such as gold, silver, and palladium, and technology metals such as cobalt and indium. 1 ton of e-waste on average contains 70 times more gold than a typical ton of mined gold, with the total value of all material in such waste flows estimated at $63 billion per year. The use of recycled raw material lowers the environmental footprint of a product, which takes into account the environmental credential of the manufacturer suppliers. This service project aims to boost a resource-efficient circular economy in the electrical and electronic sector through the development, testing, validation, and transfer of new circular economic business models based on systemic eco-innovative services that include eco-leasing of electrical and electronic equipment, product customization, improved WE management, and ICT services to support the other eco-services. Next one. The C-Service Consortium has a well-balanced composition. The C-Service Consortium brings together a wealth of expertise and resources within the areas covered by the project, including partners that propose the best solution to maximize the circular economy approach in the electrical and electronic sector by joining ICT innovations, eco-design, new logistics services, and improved WE management. Each partner has a clearly defined role within the project and will contribute a specific expertise that will enable the project's success. RTO partners, IMPLAS, Geiker, Low, and SAT have the necessary research expertise and will provide support to the other partners to achieve their objectives. SME partners, as instrumentalized, green, circularized, SFG particular, and Vertex, and industrial partners, large companies at Lexmark, Adva, Arcelic, and Rina, whose main aim in the four demos, which will integrate all the proposed new products, service, and innovative solutions. The main objectives of C-Service project are develop circular economy business model for the sector, develop IC tools for bi-directional communication and secure information, implement the new circular economy business model, validate those business models, provide key enabling tools, and maximize the innovation impact. Those are the four demos. A washing machine, TV, laser printer, and ALM. The rationale for the choice of the four target products respond to their enormous share in the total waste generation, their representativeness of the wide range of products within various electric and electronic equipment categories, and finally, their differences and particularities within the aim to cover a wider range of possibilities. Enjoy the session and see you after in the Work Package 5. Thank you very much.
Thank you, Fatima. And before we go to the next presentation, give me a second again to highlight the questions I've seen already in the chat. Yes, the slides will be distributed, and yes, the webinar recording will be provided. We will also provide you in the end of the webinar a list of links that you have a more easy way to access all materials that will be presented. The next presentation is the introduction to the circular economy business models of C-Service. I have the pleasure to have Mohamed Osmani from the Loughborough University as presenter, and he is in charge of designing the circular economy business models for the 4 target products of the project we present today. So, Mohamed, please go ahead.
Thank you, Konstantin. Can you all hear me? Yeah, so far? Okay,
Perfectly.
excellent. Thank you very much. So, morning, everybody, and thanks again for joining this webinar. So, the development of the circular economic business model in surveys addresses objective 1 of the project and comprises 2 key tasks. First of all, is to develop a circular economic business model for the whole sector, the electrical and electronic equipment sector. We call it RefCirc mode, which is a reference circular economy business model for the whole sector. Then the second task, which is the most important task, is to apply the sector level framework into 4 specific products that Fatima has already introduced, which were the 4 products that were demonstrated: washing machines, printers, telecom, which is Adva, Adva optical networking, and then with the TV sets and the displays. Next, please. Thank you. Next slide, please. So, okay. So the first idea of the development of the whole circular business model, we had to engage in the first research the key stakeholders in the EE sector across the world, and specifically in Europe, through in Work Package 1. And that's, we carried a series of surveys with the key stakeholders, including manufacturers, designers, suppliers, and so forth, and across 13 European countries. We received more than 500 responses, just to give us an idea about their views on requirements, challenges, and enablers for circular economic business models. Now, we started by looking at an organigram and a conceptual model of this, and then we structured the whole circular business model around 5 layers. So the first layer, we have to start with the business strategy. So looking at the current business objectives, and then the current business model, and how can we shift into circular economy business model by looking at potential circular economy business model objectives. Then this we informed layer 2, which is the circular economy business model canvas, which include 9 categories, which is the generic canvas for any business models. But we developed subcomponents to it, which is 36 subcomponents of the business models, which is really the core of the circular economic business models. And then the layer to the canvas was linked to the challenges and opportunities in terms of implementation, economic, social, supply chain, and technical, and associated opportunities, and then how all this is where it relates to the policies, basically, especially in Europe, in terms of compulsory, voluntary, and additional ones. And most importantly, in the end, once we have developed the circular economic business model canvas, and then components, and later on strategies, how can we measure the performance of every circular economic business model strategy through what we call the circularity indicators? Because we don't have a lot of time, this is just to give you an idea. For further details, it has been published in a journal of friendly production, the development of RefCirc mode, and this is the reference if you want to have more information about the development of the sector specific. Next, please. Having now developed the circular economic business model for the sector, we want to apply it in case studies, which is the 4 case studies. And then what we have done there is to identify how issues that are very specific to each product. And the methodology was exactly the same for the 4 products. So we mapped the RefCirc mode for the product. Then we come up with a lot of specific data collection and analysis of every product. Then we worked with Circulars, who are leading WP3, the ICT tools, GEICA and the demo partners, how to integrate everything. And then we came up with product-specific validation visit to all the manufacturers, the demo partners. And then finally, we came up with a set of circular economy actions, we call them, basically strategies, part of the circular economy business model to be demonstrated. And this is just an example of it, and then which is on the right-hand side. And then we started by having layer one, which product will be demonstrated, just giving some technical information to packaging, to production location, and to sales location, and so forth. And that's layer one, just to look at the product will be demonstrated. And then the next slide, please. So let's start with layer one. So that's the business model, for example, the business strategy. So we looked at the current business objectives, and then how can we increase and enhance circularity within the current business objectives by adding new circular economy objectives. And that's the next layer is layer two, which is really the core layer of the business models. So if you look at the first column, there is the 9 components, which are the generic business model components. Layer 2, which is we developed in 36 subcomponents. And for every subcomponent, we have circular economy actions, circular economy strategies that will be demonstrated in due course. So that's layer 2. And then if we can move on, please, into layer 3, which are the challenges and enablers. So for every, if you look at the bottom table there, so we have the category, the subcategory, and then we have a series of circular economy actions or strategies. For each circular economy action, we come up with associated challenges for their implementation and how can we address them through a set of enablers. That's layer 3. If you move to layer 4, please, the next slide. So, so we are looking here about EU policies and how all these EU policies are related to each circular economy action part of each circular economy business model that we have developed. And then the final layer is layer 5, is how to measure the circularity performance of every circular economy actions, and that's has been applied and published in a paper. If you would like to know a little bit more about it, about the circularity indicators that we have adopted in this project. And then the final stage, the next slide, please. The final stage now is we, across the life cycle stage of every product of the 4, we come up with all these circular economy actions or strategies across the life cycle stages of design, production, and then use and distribution and use and then end of life, which being demonstrated, and then Annabelle later on and the demo colleagues will go through the details of each circular economy actions. Thank you very much, Konstantin.
Thank you very much, Mohammed. Very insightful. And please let me remind all the attendees, if you have questions, you can type it already now into the chat. We will sort it up and approach then the during the Q&A round in the last 20 minutes. Our next presentation is about the implementation of the C-Service circular economy business models in the demonstrations. We will hear Ana Isabel Diaz from GEICA, and she's a researcher in the recycling and circular economy area at GEICA, partner planning, coordinating and supporting the demonstration work in the C-Service project. So Ana, please go ahead.
Thank you very much, Konstantin, for your presentation, and good morning, everyone. In this brief presentation, I will give an overview of the work we have done in the practical demonstrations to implement the new circular economy business models developed in the C-Service project. So it has already been mentioned, but yeah, the purpose of the demos, our demonstrations was to validate these newly developed circular economy business models and also our newly developed ICT tools or functionalities using 4 different products of the electrical and electronic sector. And the products have already been introduced, but we have washing machines representing large household appliances and TV sets representing the consumer equipment, both of them led by our colleagues from Arçelik. Then we have the printers and the toner cartridges representing IT equipment. This demo was led by Lexmark. And finally, we have the ALM, which is the Advanced Link Monitoring. It is a device used to monitor optical fiber networks, and this is led by Adva. So, yeah, as I said, basically then the demonstrations were our testing ground for these newly developed product-specific circular economy business models and our ICT tools. The circular economy business models, as Professor Osmani just explained, they were all based on this generic reference circ mode. And the 3 ICT platforms also were developed by our ICT colleagues. They were developed independently from one another, but in the end, they were integrated into a single platform for ease of use. I will just remind briefly that we have on the Circularized platform, which is based on the blockchain technology, and this is for secure access to materials and the components information, also for certification on ICT-based certification of recycled content. Then we have the RINA C platform, which is for reverse logistic optimization and the sustainable planning of transport routes. And then we have the Soltel platform, which is intended to facilitate communication and information exchange across all the value chain of the product. So, yeah, as Professor Osmani said before, during the validation process of our circular economy business models, we finally came up with a list of circular economy actions that were to be implemented in the duration of the demonstration. Here, this is an example from the washing machine demonstration. We have all the list of CE actions. They were selected using smart criteria. And you can see it categorized into, let's say, the 3 life cycle stages of the product, because we wanted to look at the whole life cycle of the products. So we categorized or we organized the demonstrations into stages where the design and production, distribution and use, and end of life. And finally, in this slide, I would like to just show you a summary or an overview of our demonstration goals for each demonstration. So you can see here more or less the goals per demo stage. It has to be said, however, that not all the, let's say, the demo stages were equally important when demonstrating the circular economy business models. For example, in the case of Arçelik, for the washing machines and the TV sets, in the design phase, they implemented eco-design in their products by increasing the recycled content in both of them. But we can say that the main focus of these demonstrations were in exploring and analyzing the feasibility of introducing a new eco-leasing model for both products, and also on gathering customers' feedback. And then the same model, this same eco-leasing model would include recovering the products after use and giving them a second life, also improving the repair and refurbishment operations. In the case of the Lexmark demonstration, the focus was more on the end of life, because Lexmark is mostly interested in promoting refurbished products. And so they also explored eco-design in the design phase, mostly oriented towards the design for dismantling or design for disassembly, to the ease of disassembly. And they also examined the logistics, how to improve reverse logistics to gather more printers, and how to they gathered customer feedback to assess which are the main drivers behind the customer's acceptance of refurbished products. And finally, in the ALM demo, Adva also developed in the earlier phase, they developed a newly eco-designed passive sensors for the ALM. However, we could say also that the main focus of this demonstration was on analyzing and implementing new product service system for the ALM products, and also on developing a new model, LCA-based, for lifetime optimization of ICT products, which would be extensible to any electric and electronic product. And all of this, as I said before, was supported by our ICT tools, basically certification by ICT, the logistic platforms, the smart questioning functionality for the information exchange platform. So with this, I would like to do not extend myself anymore. I will let my colleagues, the demonstration leaders, take over from here, and they will explain more in depth the results and the conclusions from the demonstration work. Thank you.
Wonderful, Anna. Thank you for that overview. And in that speed, exactly, we hand over to the first two demonstrations, which is the TV and washing machines from Arçelik. I can welcome Özlem Ünlüer. She is head of sustainability at Arçelik, the manufacturer in charge of implementing the designed business models in the television and washing machine product groups. So, Özlem, if you like to take over, please.
Yeah, thank you. Hi, everyone. It's a pleasure being here with yourselves today. So, as it's been mentioned, I'm working as the head of sustainability, and you may know the Arçelik company with its Beko and Grundig brands. So we are basically a manufacturer and service provider for domestic home appliance products. So we can move the page, please. So Annabelle has already put it into context what we have done, but therefore I'll be moving to the, please go ahead, Itziyar, with the other page. So what we learned from this project, this is the part that I want to tell you more about. So it was the first time as a novel implementation, we used 30% recycled content in the TV back cover in the PT ABS material. And we have turned this into a real life experiment by also using 40% recycled content in our TVs for the TVs that we produce for the Germany market. So up to date, we have used more than 24 tons of this recycled material. And we also implemented the QR code technology, and we somehow documented that this recycled material is coming from a trusted and reliable source. So we use the power of the ICT tool together with our partner Circularity. And aside from the project, we also partnered outside of the project to really experiment what it will be like to somehow combine blockchain technologies to show to the customers, both B2B and B2C customers, the trusted way of using circularity in a product. So, I mean, outside of this project, we are also working with them on creating a mass-balanced digital blockchain system to certify sustainable materials. And the press release has been made yesterday about this. So these were in the design phase. These were the two novel outcomes to us. And also in the washing machine, we have already used more than maybe 50 million PET plastic bottles in our products. But in a certain product, we didn't try it before because of we were skeptical about the mechanic durability. And with this project, we also overcame this issue and we expanded into another product range. So these were the novel things that we learned from this project in the design phase, and we can move forward to the next page. So in the distribution and the use phase, so here actually what we were trying to do is we were trying to experiment somehow the rent model. And when you say rent model, considering that we were in an environment of COVID, our first intention for the TVs, if there were no COVID, would be to replace them in hotels, because we thought that they would be used more and more in the hotels. But we ended up replacing all our products to try the rent model in elderly care homes and also in student dormitories. Because, I mean, for the washing machines, it didn't make sense to replace them in the hotels, because the hotels really do use the industrial types. So what we learned from this project is that there is really some customer segment that would be really interested, like the elderly care homes or the dormitories, where these products can be used by a lot of people. So what we did is that before putting those projects in those places where they would be tested by a lot of people for the rent model, we also initiated a survey among more than 30,000 Arçelik employees in different countries to test their taste for using rent products versus refurbished products. And afterwards, we also carried out this feasibility study among Arçelik for the first time to see if a rent and a refurbished model could work economically. And it turns out that for a 10-year period, for both Turkeys, because for both countries, sorry, because we place these products in Turkey and in Spain, we have seen that it does make economic sense to use the rent and the refurbishment model. But the model, the economic sense is really sensitive to issues like increasing the number of customers that will be using the service, and also the change in the price and the change in the labor costs and the logistic costs. So there really needs to be a very careful modeling and planning behind if we are to really implement this into a real life project, which we are, by the way, right now working on. So this was one of the things that we saw, that it does make positive business sense. And also we have seen that among this internal survey, I mean, people are more willing to rent the products if the same quality and the warranty terms apply. So it's really important that they get the same warranty and the quality promise behind. And also the refurbished product choice, it's really sensitive to the price of the product, because people have a lot of constraints considering the hygiene of the product and the quality and the durability of the product. And 78% of the people responded that they would only buy if it had a really, better benefit in terms of pricing. So we can move on to the next page. And also in terms of the refurbishment, this was also an interesting part. We have worked with our partner Emaus in Spain, and this was the first time outside of Turkey in Europe that we worked with a partner, because in Turkey, Arçelik has its own refurbishment centers where products are already refurbished, but we didn't practice this outside of Turkey in Europe, in the EU. So with Emaus, we saw that there is a chance for us to cooperate together, especially in terms of the refurbishment of the washing machines, because the refurbishment of the TVs, it's a really burdensome process, and there's a lot of technical knowledge that needs to be carried out, and the technicals, they should be really skilled to refurbish these TV products, and there's a lot of danger and hazardous concerns as well. So we saw that the technicians, they're better equipped to really refurbish the washing machines, but there's a really conflict here, because despite the fact that the washing machine refurbish is easier, the survey results show that people are more willing to buy a refurbished TV than a refurbished washing machine. So this really brings the fact that there needs to be a really investment in the infrastructure to refurbish those TVs by refurbishment centers. So also the LED panels that are inside the TV, they're really the ones that get really easily broken. And this makes it really hard to repair the TVs. So also Emaus, our partner that collected these products from the dormitories and the elderly care homes, They then activated this living lab activities, and we can move on to the next page to show that the living lab results show that participants are, as I've mentioned before, are more interested to buy a refurbished TV than a refurbished washing machine. And they really like to value that the product has been refurbished according to hygienic issues, considering the washing machine refurbishment. And they want the same warranty and the same warranty terms, and they really want a huge discount on the product if it were to be used again as a refurbished product. So we can move on to the next page. We also tried the 3D printing for the first time with the sake of this project with our partner Particula. So in the washing machines, because the washing machine is a very dynamic product that works under a lot of load and under a lot of conditions like the heat, the detergent, it's really hard to find the part to really 3D print. And we focused on the plastic parts. And in the plastic parts, we needed to focus on smaller parts because the 3D printers were more suited to print those smaller parts. So first we tried the washing machine drawer, but the detergent box didn't turn out to be a good option. And then we moved to a liquid detergent container. And in the liquid detergent container, we have seen some problems with the visual item, and also there were detergent cloth because of the 3D printer's quality of the material quality. So therefore, it didn't pass the tests. But there is still some room to test, I mean, maybe some other parts, some other materials, but the initial results didn't pass the tests. The same also happened for the TV, because we tried the material in the TV 3D stands, and they also failed due to the durability concerns in the larger TVs that are heavier. So therefore, I must say that these two tests failed it. We can go on. You can see the pictures here. I mean, we can go on if you like. I mean, you also see the pictures for the TVs. So here, in the end of life, thanks to our partners, I mean, with Greentronics, they looked at our washing machines, the end of life washing machines, and they tested how long it takes and what would be the cost of dismantling the washing machine. So because we have our own dismantling and WEEE facilities, and because we also have our refurbishment centers in Turkey, we know the costs in Turkey, and the costs weren't really competitive compared to our own costs. So we see the same for the TV side as well, but the TV side was interesting because two recyclers, they provided very different time to dismantle the products, as well as very different costs to really pack the parts or ship the parts or labor hourly rates. So it really depends on finding or creating the right infrastructure behind the dismantling process, so that the dismantling business becomes feasible, so that people would be willing more to buy those dismantled products, the parts as spare parts. So the recovery of WEEE really needs to make a cost sense, to make a business sense, and we couldn't sense it considering the high costs in this project. We can go on. We can move on to the next page. Another thing that was tried is the plastic material from these end-of-life TVs and washing machines. They have been recycled, granulized again. And I mean, they were like 100% the previous material. And the test results showed that they can be used aside from some mechanical properties which needs to be improved. I mean, if we were to really include maybe some small amount of virgin plastic inside, then the durability and mechanical properties would even pass Arçelik's specs. So this shows that these materials can be recovered and then can be reused. As I've mentioned before, we have W3P facilities in Turkey, but not in Europe. So, I mean, recovering those materials from a recycler in Europe and then using them in our production will make business sense for us in our European production facilities. So, I mean, there's always room to look for such activities, and it's proved that this works. So this is all from my end, and thank you very much.
Thank you, Özlem, for the overview on these demonstrators, TV and washing machine. And thank you for the attendees to raise the questions already. I see there's several interests, and as said in the Q&A session in the end, we will address that. The next presentation goes about the ALM demonstrator, which is a monitoring equipment used in telecommunications. And I have the pleasure as next speaker to introduce Klaus Gobe from ADVA. He is a Senior Director Global Sustainability in ADVA, and the manufacturing company is implementing new circular business models in exactly the demonstrations ALM, what we now learn. Please, Klaus, go ahead.
Thanks, Konstantin, and hello, everybody, also from my side, and thanks for your interest and participating. It became a running joke in the project that we should have used another name rather than ALM, because nobody knows what an ALM is. Technically, by the way, it's an optical time domain reflectometer, which would not have helped neither. It's a piece of equipment that can monitor ICT infrastructure, or if you consider that there are optical fibers in buildings and elsewhere, it can also monitor these buildings, etc. Next slide, please. Quick overview, coming back to what Mo and Annabelle said, we, of course, during the project only investigated in some level of detail a subset of the canvas listed here, and not all of these were investigated in the same level of detail, and I will only highlight on more or less on two of our actions taken. And those canvas aspects not listed here were discarded more or less pretty quickly in the beginning of the project, and they were not regarded at least productive for ICT network or infrastructure equipment. That doesn't say they are not interesting for many other EEE around. Next slide, please. Okay, so here's an overview on product service systems taken from a major reference, but further developed. So we believe this is a pretty useful overview, and on different PSSs, where you can find toward the right-hand edge what is called product as a service. You may rephrase it by something else. Service as a service, for whatever reason, doesn't seem to make much sense, but it's more about offering a service rather than a product. And for ICT infrastructure equipment like the ALM, and by the way, though being maybe a niche product, the ALM is representative for ICT infrastructure equipment. We had to discard several pathways through the diagram, mainly the ones with product sharing, intensified usage, product system substitution, and displacement by more resource intensive systems. Why? Because ICT network equipment since decades optimized product sharing and utilization. So that path was gone, and ICT in general is the substitution for many other things. consider a download of a CD rather than driving downtown and purchasing the CD. It itself cannot be replaced, so that path is also gone, and the rest was investigated. Next slide, please. And by the way, a fun fact, of course, Adva did try to do followed several attempts in the last, say, 6 to 8 years to doing leasing business and associated things, all of which, for several reasons, failed in the past. Some of these reasons were ICT specific, not all of them. So we did an analysis. I do not want to go into too much detail here. We did consider all relevant financial or monetary aspects, as well as relevant environmental aspects. We did not only do this for the ALM, we did complement it by completely different equipment from our portfolio, at least, and the analysis in general, parts of it are, of course, relevant for other EEE as well. And we did also analyze both our view as the selling or offering party and the customer's view as well. And that we did for several PSS, which are once back, please. Okay, and the two diagrams only show two examples. Again, I will not go into too much detail here. They show for an ALM configuration, that is for a monitoring system, the cumulative customer cost, left diagram, and the cumulative net present value, that is the money we would get when either leasing it or selling it. And such diagrams were developed for various PSS. Also, of course, other parameters like the one shown on the next slide. And what we can say from these analyses is already that several PSS absolutely do seem to be feasible. Although, as said in the beginning, some of our attempts failed in the past. So we also investigated over lifetime the cumulative global warming potential, GWP, as possibly the most relevant life cycle assessment LCA parameter around today, of course, driven by global warming. We could, of course, use other LCA or life cycle assessment parameters as well. We did so because we think that the basis for any knowledgeable decision must be proper end-to-end life cycle assessments. And what we found here, interestingly, and it seems to contradict a little bit what can be heard elsewhere, is that product service systems, or any product service systems that in the end do have take-back or a take-back obligation, perform similar, if not identical, in terms of environmental parameters. So what we can often hear that eco-leasing is the crown of creation, we couldn't confirm, because as soon as there is the take-back obligation at end of life, EOL, the analyses showed that the respective PSSs performed more or less identical. And by the way, what we investigated in detail is, because that's our today's business, sales. I can't see the slides anymore. I'm now sitting in front of a black screen. I don't know what that means. Can you still hear me?
Yes, we can, Klaus.
Okay, I think I can proceed. So the first PSS, because that's our today's business, is selling products as usual, but together with maintenance contracts. That's clearly a strategic approach of Adva, plus take back in the end. And the two others were two versions, no, one's back, please. Two versions of leasing. One where only the product itself was leased, but operated by the customer, and the second where the service, the product offered was leased. So something completely different. And both have their place within our market and our portfolio, and of course also other EEE markets. Now, next slide, please. Then we also conducted a substantive lifetime optimization analysis, where we developed what is called UPR10 here, a ratio of basically use phase global warming potential over production global warming potential, where the first 10 years of usage are considered. Why 10 years? Because we are after long usage anyway, which, by the way, is fact for ICT infrastructure equipment, and also to level out certain effects during that. And what we found is, and if we display the cumulative lifetime global warming potential over time, what we find is that for the ALM, a replacement, say after 8 or 10 years, by a more efficient successor unit, and successor units are always more efficient, doesn't make sense. You can see that the curve with replacement never ever meets the original curve without replacement. What does it mean? That piece of equipment should be, and in brackets, is designed for longevity. And as a matter of fact, ALM systems can easily withstand 15 years and their passive sensors even decades, if you will. This is not true for some classes of both ICT equipment and even other EEE. You can see it in the right-hand diagram, where you see that maybe potentially even by several replacements by more efficient successors, you can decrease total lifetime global warming potential, that is emissions. And that, of course, does include the production, the complete production of the successor units. Why? Because such machines, I took as an example here a fiber optic transmission or transport system called Terraflex. They are completely dominated by their use phase in the LCA. And these machines should be taken out of service after a certain period in time. This, by the way, is the test that is required in the EU taxonomy, and it is called there the do no significant harm principle. So if we apply this principle to certain circular economy actions, we have to prove that these respective actions do not harm, in this case, climate change. So this parameter can exactly be used for that. Next slide, please. That is okay. So in conclusion, what we found for ICT network equipment or infrastructure equipment is that of course the respective equipment can be designed for longevity and be maintained and repaired, but the reuse and refurbish loops we have at least to put a question mark behind for the reasons mentioned. And this leaves for ICT infrastructure equipment the innermost and the outermost loops as the most relevant, where of course certain improvements regarding recycling are also required. We also found that several PSS are not only promising but really feasible for our products, and consequently we will exactly extend that business. Brings me to the end. Thank you.
Thank you, Klaus, for this demonstration of the ICT equipment, monitoring equipment, or let's still call it ALM, although nobody knows what it is. Nice thing on the side. The next presentation deals about the printer and toner demonstrators, and it is introduced from, or it is presented from Patrick Carminiati from Lexmark, and he is head of sourcing and manufacturing at Lexmark, the company that demonstrates the implementation of new business models for the printing sector in general. So, Patrick, please go ahead.
Thank you very much, Konstantin, and thank you very much to all of you on online for your interest in the subject matter. Obviously, everyone knows what a printer is, so I won't extend much on this one. Just want to mention that here we'll talk about B2B as opposed to B2C. So bear that in mind for the presentation. Just go one slide before Itzia, please. Objective of the presentation is really to trigger your curiosity, so then you can go into the detailed deliverable which are available on the internet site. Title of the presentation: what are customers' expectations toward refurbished printers? How to build an attractive business case for the refurbished printers. This is what I propose to answer during the next 15 minutes. Next slide, please. And therefore, I do propose you to go through the following agenda. So within C-Survey, we set various activities which will support this presentation. So the first point is customers' expectation. Everything starts with the customer, so this is a really important one. Then I will propose to go for the current state of this industry and the associated challenges which are faced as it relates to refurbished products. To then jump into the C-Survey demo and activities aiming at addressing the challenges that we'll have highlighted, to then conclude. Next slide, please, Itzia. So, customers' expectation. We drove several activities within C-Survey, from mass mailing to product testing at customer location, aiming at better understanding what the expectations are. No surprise, the willingness of customer to buy refurbished product is high. On the other hand, it comes with the expectation that those products would cost up to 50% less than a brand new one. And interestingly, it comes with another expectation that those products will perform same as a brand new one and with the same warranty. So you can understand here that there are interesting challenges to be addressed. Users don't mind too much about cosmetic defect on the product, which is something new for us. And it looks like customer acceptance have evolved over time. Key focus remain on performance. If you look at the purchaser perspective, this is different, of course. Their focus is on price, and price again. And interestingly, minority of customers, they want or they need the latest technology in their products, which is an important point. Next one, Itzia, please. So what about the current state of this industry? Let's distinguish printers and cartridges. Printers, like smart printers, they are designed to last long, 7+ years, depending on the usage of those products. Now, same as a car, they require some maintenance on a regular basis to change some spare parts. Interestingly, these are considered as an investment for OEM, meaning that they are sold at cost or even sometimes less than cost. And finally, refurbishing a printer comes at cost. And this cost is made of 3 major elements: reverse logistic, material, and labor. And these are 3 challenges that we'll see in the next slides. Cartridges, it's a different subject matter here. Lexmark, we manufacture cartridges for 25+ years, and we do remanufacture up to 40% of the cartridge that we sold in Europe, which position us as being a leader in this area. Products are obviously designed to be remanufactured, and they can be remanufactured up to 10 times with the same performance than a new one. Both products already contain a certain level of recycled resin, and based on all that, you understand that the focus for C-Survey has been mainly on printers and less on cartridges. The last challenge, the demand. The demand for sustainable product raised post-past year, no doubt. On the other hand, it's still at a low level. So there are a few things to be done to raise this demand at a higher level. Next slide, please, Litzia. So addressing the challenge. As a reminder, we have reverse logistic, material, labor, and demand generation. Reverse logistics. So some of the activity that we develop within C-Survey aim at making customer life easier when it relates to get rid of a product at its end of life, or when its use and they do not need it anymore. So we implemented some digital tool, which are now in place for months and which brought the expectation, so to ease customer life, but also they reduce cost of processing these take back and buyback devices. Now we also run some competitor interview, and competitor shares the same challenges than we do. And as it relates to reverse logistics, the question pop-ups, what about sharing reverse logistic cost with competitor? We haven't pursued this as this is not in the scope of C-Survey, but this is in the radar screen moving forward for us. We also work with ICT company of the consortium to see how we can optimize the consolidation of pickup of our product to optimize the cost and the associated CO2 emission. And this has been successful. 2 highlights. We need to solve the printer as soon as possible in the process. It may seem obvious, but this is something that we have to focus moving forward to determine whether a product can be refurbished or has to be recycled. And this won't be the same process and the same cost. So an ICT tool here may help. And another one, still on the last one, is we have to make sure that, and this we play on word, but products are considered as end of life when a user do not need it anymore. But in fact, we should change this and consider them as used product, which can have a second life or from which we can get spare parts. Because yes, we can properly recycle a product, but this is the last, the ultimate scenario. Ideally, we need to extend the life to refurbish the product or to cannibalize spare part from the product before thinking about recycling. Next one, please. So material challenges. Here we work with the 2 recyclers from the consortium to actively work on what about having a positive business case supported by an ICT tool to get recyclers dismantling those products that arrive in their premises rather than recycling them and dismantling them for the purpose of recovering spare parts. We run various activities and we end up with some positive outcome, which is a good news. On the other hand, 2 bottlenecks. Product availability at recyclers' location. Those past 2 years, very few products due to COVID, question mark, because during COVID, product scarcity drove product lifetime extension naturally by customer. And the second challenge is the shape of the product. Product ending up at recyclers end up most of the time in bad shape because they are handled as waste. It's that simple. So it drives the team to say that we have to think upstream in the supply chain. And finally, on this one, we interview a resource recovery company. I won't give you more detail on this. I invite you to look at the deliverable. It could be a good path moving forward. We're using resin, it's pretty straightforward, no major findings here. I leave you reading the line. 3D printing, very limited opportunities. We tried visible parts, functional parts, none of them passed the test. Just a couple of packaging parts passed the test. Great findings, the one before last bullet here is the cosmetic defect. Interestingly, we as OEM manufacturer, we had paradigm that customer need a product which looked like brand new. And looks like customer acceptance evolved was past year and it evolved positively. So it drove Lexmark to revisit its cosmetic spec. This has been changed, which help us to bring some offer to customer, to bring some more competitive offer that we did before. And it also generates a new sales dynamic, which is very interesting. Yield study, the last point. What do we mean by yield study? Just assume you get 100 products in your premises, 100 used product. If you want to refurbish those 100 products, you need the associated spare parts, and it will drive a certain cost. Take the other option to say that you will refurbish only 50 products. Then you can cannibalize the other 50 products, which will drive a lower cost. So it's a trade-off in terms of cost to offer customers the product and the number of units that you will refurbish. And you'll get some much more details in the deliverable, obviously. Next one, please, Itzia. So labor challenge, 2 pieces here. If you want to offer customers the right performance, the right warranty, you have to get a robust process to refurbish products. And there is a one-shot cost to qualify the process. No big deal, several K for a family. Then efficiency. If you are in manufacturing, you know as well as me that volume is really key. And today the volume are pretty low. So we work with our subcontractor to refurbish product to put some numbers together and determine what can be achieved. And 2,000 units of the same product would be the trigger to drive up to 20% efficiency, which is not a neglectable number, and 2,000 units is not a big number as well. Next slide, Sia. Last challenge that we mentioned before, demand generation. So few things here. And this was confirmed also with a competitor interview. We need to incent our sales team to sell those products. Believe me or not, this was not the case a few years before. So now we develop some program for our sales team to educate them on those products, also to change the paradigm that everybody has in their mind that a refurbished product is a lower performance product. This is not the case anymore. Even customers have changed their mindset or their view on those products. So this is ongoing, and we also push our sales team to promote take back, buy back program, which are important if we want to boost the circular economy of this sector. PSS is also seen as being a major enabler. OEM are the one who better know than anyone else their product, when to maintain them, whether they can be refurbished or not. And here as well, a new dynamic within the company where we launch a subscription program, which is a pay-per-page. This is not something new, but there is a new dynamic in this area. One before last one, sorry, just on the, customer education. It is needed. I mean, we can develop nice program. If we do not inform customer and educate them why we launch those program, it is useless. Also to educate customer on the environmental impact. The LCA is a powerful tool, and we did many activities here related to LCA within C-Survey, where we can use the outcome to communicate to customer, and customer are now much more sensitive than they used to be. So here Lexmark is currently developing a marketing campaign, which will be live early next year in this direction. So last one, regulation, financial incentive, like reduced VAT can help. Go ahead, Itzia. It's fine. You're fine. And as a conclusion of what I just said, a product, they need to be designed such a way their lifetime can be extended and such a way they can be easily refurbished. It is obvious, but all product may not be designed such a way. Design should allow also for software, firmware. Technology evolved very rapidly those past year. What's in front of us, we do not know, and we need to keep this flexibility. Salesforce need to be incented to sell such program of refurbished product, customer to be educated. Legislation support will be required at a point of time. And a challenge, an interesting one. If you want to sell refurbished products, you need to have used product. And at a point of time, you won't be able to sell 80% of what you sell as refurbished product because you still need new product to place on the market. So there is an interesting equation here, which is not yet solved to determine what the trigger is. And finally, PSS seems to bring the most efficient solution, as OEM would retain the ownership of their product and can optimize their lifetime. I think that's all for me. Thank you for listening. And now I turn to the next speaker.
Thank you, Patrick. Very nice insights and the identification that scrap goods, take back goods is a limited resource. Let me hand over and close the loop of our circular economy session with the presenter Fatima from the beginning, and she will summarize what about the demonstrators, what we learned. Please, Fatima, go ahead. And after your presentation, then we will address the question and answers. Please.
Thanks, Constantine. Hello, to everyone. One of the main objectives this project is to validate the new circular economy business models by verifying their life cycle sustainability, LCSA. The sustainability analysis methodology consists on bringing together the following concepts related to the assessment of the environmental, economic, and social impact of a product or service. In this case, the three concepts related are life cycle analysis, LCA, life cycle cost analysis, LCC, and social life cycle analysis, so SLCA. The validation of the four new business models and their target products, T-service products, and related eco-services has been determined by means of life cycle sustainability assessment. The C-service develops the large-scale demos involving industrial partners across the whole electronic equipment value chains in Europe that will be produced in the project together with the target products for each electronic equipment category. Next slide, please. Yeah. As you can see in the slide, TV life cycle analysis, LCA, we have used the RISC method, which involve 21 environmental impact categories, different categories considered. The first graph represents the impact reduction for each one or for 21 impact categories. It should be noticed that the reduction of 81% of the categories considered, it's between 20 and 45% of the total environmental impact categories. The biggest reduction are shown by marine eutrophisation, freshwater ecotoxicity, and marine ecotoxicity. And the smaller ones are water consumption, ecosystem, and human health. If we focus on the next graph that shows the global warming potential, we can see the reduction is 44% and is caused by the manufacturing phase, generating a total reduction of more than 21%. Next one, please. If we, as you can see in this slide, we can see the cost and the social analysis. I have to say the internal costs are the direct cost of acquisition, use and maintenance and end of life of the product. External cost includes the indirect cost associated with the environmental externalities calculated according to the RISC method. External cost is an approach for monetizing environmental damage. The biggest cost reduction is caused by the external cost, in other words, environmental cost. As for social analysis, we can see how all categories improve in the next product. The deepest social cost reduction is human health. Next one, please. So, washing machine, life cycle analysis. It can be seen that in case of washing machines, the percentage of reduction is lower than in the case of television. Only in 24% of the categories, an impact reduction of more than 15 is observed. The biggest reduction, example, are resources, ionizing radiation, fossil resource scarcity, and global warming potential. The smaller one, the smaller reduction are shown by stratospheric ozone depletion, ozone formation. In the case of, if we focus on the global warming potential, the biggest reduction are 1.3% of manufacturing phase and 0.9% of end of life. Next one, please, Cecilia. Thank you. You can see the cost and the social analysis of washing machine. The total reductions in environmental impacts are lower than 1%. No cost reduction can be seen. The same will happen with the social analysis. Next one, please. In the case of the telecom device or the ALM life cycle, it should be noted that the reduction of 38% of the categories considered is between 20 and 40% of the total environmental impact categories. Next one, please. Cost analysis and social analysis. In this case, the greatest cost reduction is produced to internal cost with a reduction of 44%. In the social analysis, a reduction of 47% can be seen in all categories considered. Next one, please. Thank you. Here can be seen that in this case, in the case of the washing machines, the percentage of reduction is lower than in the case of the television and the telecom device of ALM. Only in 29% of the categories, an impact reduction of more than 4% is observed. For example, the biggest reduction is shown by marine eutrophication. In the case of the global warming potential, the biggest reduction is 9.3% and is caused by the manufacturing phase, generating a total reduction of 3.3%. Next, please, thank you. Also, the costs are similar for the reference scenario and for the C-service new product. In the social analysis, 5% reduction can be seen. Finally, we can see a slide showing material circularity indicator, MCI. This indicator goes from 0, fully linear. Thank you. This indicator goes from 0 to 1. 0 means fully linear product, and 1 means fully circular product. We can see the variation in the slide for the 4 C-service products, and we can see the 4 products increases this MC indicator, being the ALM or the telecom device, the one which shows the biggest variation. That's all. Thank you for your attention.
Thank you, Fatima, for that result overview. And let me now open the question and answer section. We have 12 minutes left before we come to the closing words. I would say we can dare to go through the main questions. Some of them have been solved already in writing, but let me start from the beginning. During Mohammed's presentation about from Loughborough University about the basic and the research, there was a question: did the background research in this presentation also identify existing circular economy models? Then there's an example from few years with a milk bottle, the milk bottle made, filled, delivered to doorstep, collected from the doorstep, taken back to the dairy, washed, refilled, and delivered again. In the 1970s, this was also in the ELV card. This is the circular economy model in its simplicity. So was that considered? And I think we have heard several parts of the answer, but Mohammed, you can certainly say something.
Thank you, Constantine. Thank you, Constantine. I think that's a very fair question. So just to give you an idea about the development of this. So the project started in May 2018, and the business model were completed by 2019, so less than a year. So there was a lot of activities there, which include an extensive literature review on reviewing, classifying the main existing circular economy business models and assessing the relevance to the EE sector. And we looked at standards. For example, in the circular economy business models that we looked at is circular supply chain, recovery and recycling, building products to last, sharing platforms, product PSS as we adopted later on. We looked at other aspects as well, like hiring, leasing, asset management, and so forth. And then we looked at different approaches, circular economy business approaches for products, for example, durable goods, longer lasting goods, refillable parts, like you were saying about the bottles, one of the comments. And then we looked about service circular business model approaches, subscription-based services, pay-per-use, crowd-based services, and so forth. And then after that, the conclusion was a variety of classification of circular economy business frameworks. There were different number of keywords used, but there were agreement on the main component and use of different terms. And broadly speaking, in terms of classification of circular economy business models, we looked at circular design and manufacturing, which were focused mainly on reduced use of primary resources, the reuse of renewable sources. Then we looked at circular use, so mainly based on sharing platforms, product PSS, product as a service, and then of course circular end of life, focusing on recovery of resources that are used to optimize lifetimes. And these are the three stages that we adopted for the demonstration. The design and of the products, the use phase, and the end of life phase. That's just in a nutshell regarding the underpinning research in terms of review, examination of existing circular business model, and most importantly, how relevant they are to the EE sector in general, and specifically later on to the 4 products that have been demonstrated in this service.
Thank you. A very, very comprehensive answer, I would say, and I hope that was addressed in full satisfaction. But there was a second question, and I think we also might have opinions from the other speakers, although it was already addressed during your presentation, Mohammed. Do you think that the framework you developed could be adopted in other sectors for other waste sources? I think also a very logic and fair question. So
yes, I think
someone to start.
Absolutely. I think it's a very good question and fair question and relevant, and it's part of the project as well, because we have work package about replicability of all the solution of this service, including the development of the circular economy business models. And the multi-layered framework, the 5 layers, will be adopted or have got the potential to be adopted by other sectors. Actually, we are adopting such a framework for a UK-funded project, which is Circular Economy Centre for Mineral Construction Base Materials in the UK, which is the only actually construction product circular economy centres in the world. And we are applying the approach about the layers of looking at the business strategy, moving to the canvas, and then looking at opportunities, challenges, and enablers, and then finally coming up with circularity indicators. We are also looking at it in terms of transportation, between what we call the transportation machines, i.e. The trains, the aeroplanes, the cars, and the ships, and then how to be used in there. And then they've been used as well in other sectors like textile and so forth. So broadly speaking, it's a framework that could provide some guidance in terms of shifting from current business model to circular economy model in any sector as a broad. Of course, there will be characteristics later on in terms of the difference in terms of subcategories of the canvas, because we come up with 36 subcomponents for the canvas of for the C survey. There will be others. The same thing will be the challenges could be different, and the same thing for the policies.
Something to add from one of the other speakers to that topic? Otherwise, we have enough other questions. There was, I think we skipped that because there was a debate about did you use ITU-T resources, specifically the L1023? I think Mohammed already addressed what was taken, and I think that was also discussed in writing extensively between Klaus and the requester. Let me jump to the next. In terms of circularity, there is, and it was addressed during the presentation of Arçelik. Maybe Özlem, you might respond to that, but certainly open to the audience. In terms of circularity, there is a need to look upstream pre-manufacture to understand the resource use mass balance analysis in any circular economy model. In principle, upstream, what you have taken into consideration, I would interpret that. Consider plastics. Upstream 400 million metric tons of virgin plastic are produced each year, and only 9% is actually recycled. When designing products for reuse repair, should plastics actually be used in manufacture, given the facts above, to ensure waste prevention and downstream environmental impacts?
Well, I would say that first of all, plastics are a part of our life and they're used in a lot of products. So the question would come down to, are we going to eliminate plastics, completely, or are we going to really initiate the infrastructure to recycle the plastics? And it's not only up to companies to do that, it's up to the municipalities, the government, and the companies to create that infrastructure that will find the means to recycle that plastic. The world itself is 9% circular, not only for plastics, but for all materials. So it's not only a question of plastics, but it's a question of increasing the circularity overall. And also, okay, let's replace plastics with something else. But then, in terms of steel, let's say we're going to use more steel, then the emissions that comes with producing that steel is even higher compared to the emissions that come with producing that plastic. So it's really a matter of increasing that recycling percentage, I would say. And of course, in terms of the design, there's a lot of means to increase the plastics used. But it all comes down to how can we use it, over and over again, instead of totally eliminating it. If I understood the question correctly, I don't know.
Klaus, yeah, I would have one addition. There is at least certain, let's say, subsectors where indeed there are massive attempts for eliminating plastic, or at least eliminating single-use plastic. In our case, that would be packaging. I know we had some debate on packaging, but as a matter of fact, it is now a strict requirement of almost all large customers to have plastic eliminated in packaging of ICT infrastructure goods. And in ICT equipments, to finish with that, plastic is a minor contribution according to LCA.
Yeah, the same goes for our products as well. 80% of the emissions come from the use phase of the products. In terms of the waste problem, it is a huge problem, the plastic, but it's really like this infrastructure creation is what we are lacking, I think. This post-consumer plastic, it's also really hard to find the post-consumer plastic. And most of us manufacturers, we use the post-industrial plastic. And that's not really addressing the problem as well. So it's really important that this post-consumer plastic can be found and collected, sorted, and then recycled.
Wonderful. So a clear distinction between fast-moving polymers and engineering polymers in products. That's my summary, what I heard from the answer. There is 1 minute left and 2 questions. So Klaus, you had already a debate in the chat. If you have something to add, feel free to say it here. Otherwise, I would jump to Patrick and the question that is rose when Patrick presented. So, Klaus, do you want something to add?
No, I think the respective questions have been answered or will be answered via email.
Super. Then, Patrick, there was a question very specific to the printers regarding Lexmark printers. Do printers have type 1 eco-labels? Well-known eco-labels make it easier for customers to choose environmental friendly products, both consumers and professional customers. So, and that would be then the last question, in my opinion, or your answer would then also be the closing.
Okay, so unfortunately, I'm not an expert in the eco-label subject matter, so I would be cautious in answering. But as it relates to printer, we do a lot of PCR, so post-consumer resin as example, in our printer. So this can be found in our CSR report. What we are now launching is really a big push on refurbished printers. And here there will be different category of refurbished printers, but this is not linked to an eco-label. Sorry, I can't give a better answer at that stage, but I'm open to take the question and carry on with the internal expert as relevant. So if the person want to send me by chat or by email, better the question would be my pleasure to carry on.
Super. Thank you, Patrick, for that offer. And with this, let me introduce the closing remarks. You see also in the chat several links on further information about videos, about platforms, social platforms where you can get more information. But let me pick out and highlight specifically the October 19th in Brussels, where you have, or where CSRVs has the final event, and there more details will be expected, and possibly the homepage http://c-servisproject in one word.eu. And with this, I cordially thank you, the presenters, and even more the attendees, for their interest, for your time on both sides, and for the questions and the follow-up by email. Thank you and talk soon.
Thanks, everyone. Bye.
Thank you, Konstantin. Thank you.
Thank you.
Rest of the audience.
Bye-bye.
Thank
Bye.
you so much,
Thank you.
Konstantin. Thank you. Bye.
Thank you. Bye.
Thank you very much. Interesting presentations. Goodbye.